I'll just reset my timer. And here we go. Great. Hello. Very kind of the organizers to keep me right next to Kyle. The bar is so high, and I'm just 5'6", but let's get started. So, hello. I am Ujjwal. Thanks for the great introduction. I'm here to talk about multi-core JavaScript. But first, because I love myself, let's talk about me. So I am Ujjwal. You can find me on the internet as Reisakuken. Don't ask me where that's from, but never mind. What about me? So oh, okay. This doesn't work, or does it? Huh. No. Oh, okay. Whatever. I am a compiler's hacker at Igalia. Sorry, the animations don't work. As mentioned in my bio, I am a co-chairperson of TC39. If you don't know what that is, I hope that I can give you an idea by the end of the presentation. I'm also a co-editor of ECMA 402, which is the internationalization API of JavaScript. In a previous life, I used to work a lot on Node.js. I'm still involved. And yeah, I love dogs. So hello. One thing that I want to mention before I start is that everything that I'm going to talk about is a lot of interesting stuff. I hope you like it. But it's not something that I am doing or have done single-handedly. I stand on the shoulders of giants here. So this is part of a joint initiative between many talented people and organizations that support them. So thank you, everyone. A disclaimer before we start. I have a lot of slides, and they're very verbose, so sit right in. But I'm going to blaze past some of them. Don't worry too much. Don't read all the words. Focus on me. And I promise to give you the link by the end of it. But let's start. So JavaScript is ancient, right? I don't know how old most of you are. You look young. You look great. But I'm young. I'm 23. And JavaScript is older than me, for sure. And sometimes we don't realize, like, some of the languages that we work with or compare JavaScript with are so much younger than JavaScript. They don't have the same kind of baggage that we do. But to demonstrate how old JavaScript is, we have photos of some of the early users. But JavaScript was conceived doing a lot of work here. But JavaScript started in December 1995, which is quite old, right? Back then, computers, well, CPUs, looked kind of like this. So this was like the top-of-the-line Intel computer. It was 200 megahertz, and it had a single core. And if you're into AMD, that's what it looked like. But for a lot of us, we weren't using these top-of-the-line CPUs. Much later, I, for instance, was using Celeron, which is what most home users had. This is me trying to play. It didn't work. But back then, CPUs were very different, right? CPUs used to scale with frequency. If you remember, you would obsess about, like, OK, wow, 4 gigahertz, this is great. But now CPUs don't work this way. Modern CPUs, like something you'd have in your phone, or even something you'd have in your new computer, scale by cores. They have many cores, and we can go really deep. It deserves a talk of itself, really, to go into like how these cores work. But the general idea is that now we pack a lot of cores into a single CPU. And because JavaScript was written in an era where CPUs were so different, hardware was so different, it was designed to sort of work with that kind of hardware. But how does it move to the future? So let's talk about concurrency. By a quick show of hands, how many of you know about concurrency and parallel programming? And OK, few. So OK, let's get a little bit into it. I'm sorry if I'm getting too deep, but imagine I wanted to get a bunch of stuff done. It's rare, but sometimes I do get stuff done. Every task would take a certain amount of time, right? I could do all of them, as you'd expect me to. But if the tasks were not really dependent on each other, I could try something smart, right? I'm an efficient person. So if I had the ability to perform multiple tasks at the same time, I could do them simultaneously. The problem, so this is like a multi-core scenario, right? You have multiple cores, and you can do all tasks in parallel. Now, if you see, like at the end, the time taken is essentially close to half, but not exactly, right? Because if okay, let's talk about it later. But this is what we are going to call, in the course of this presentation, the thread-like model, right? If you are familiar with other programming languages, they call them threads. In JavaScript, we call them workers or something like that usually. But in the course of this presentation, we're going to call them threads. So I could try to make this more efficient by sort of min-maxing all the tasks. And if you see, there's a difference here. So if I did it better, I could save some time. But this is difficult, right? How do you figure out what to do when and on what thread? It takes sometimes you just have to wing it, but it's difficult to make sure that you're squeezing all the performance out of your course. So because this is so complicated, in JavaScript, we usually stick to another model, right? So if we take a look at the tasks that I was performing and take a deeper look into them, you'd realize that these tasks are not always doing something. A lot of the time, these tasks are just waiting for something to happen. Imagine a function like this, right? It's fetching something and then doing an operation, then fetching something else. And in many of the steps, you're just waiting for something to happen. So a lot of time in the task is actually spent waiting and not actually doing anything. Network calls, by the way, are not the only source of waiting, but they're definitely the most common, especially if you're doing front end. What if I did something weird? What if I kicked off all the tasks at once, even if I could do just one, and then executed whichever was ready to go, whichever wasn't waiting? So let's say I have all these tasks, and I start, and then I kick off the first, and then the second is ready, and then I kick off that, and so on, right? This is how JavaScript works in most runtimes that you use. This is how JavaScript works in Node or in browsers that you like. This is a task loop or an event loop, as you might say. So these are the two models that we're going to talk about. This other one, I'm going to call it the web-like model, because that's what we're more used to on the web. And so there's these two models, which is the thread-like and the web-like. But how do we deal with them? So these two models have different pros and cons. Well, they have different features. And the problem with the thread-like model, at least in my opinion, is that it forces you to think about things like data races, right? If you are writing code that is simultaneously changing things, how do you make sure that it doesn't have any race conditions and so on? So what we have in JavaScript is sort of a mix of both of these models, right? And yeah, I'm just going to race past this. But the idea is that both of these models have something going for them, but at the same time, not everything. So this means that in TC39, we have a problem. What do we focus on? Should we focus on the web-like model, which allows developers to more easily write code and not have forced them to think about some of these synchronization problems? Or do we focus on thread-like, which allows developers the freedom to essentially take out as much juice as they want from their hardware? And we tried to solve this problem by doing everything, because why not? But we cannot do everything at the same time, so it needs to happen in phases. For phase one, what can we do? For web-like, We can have language support for asynchronous communication. So there's all these tasks that are firing at the same time, right? How do you communicate asynchronously? And you need the ability to spawn units of computation. You need to start workers. On the thread-like side, you need something to have some way to share memory among these different actors. And you need some primitives to do synchronization. What do you know about synchronization? So when you have multiple threads and you're firing off tasks on each thread, you would need some way to synchronize them, right? You need some atomics, for example. You also need the ability to spawn threads, because without that, you don't have anything. But if you notice from the last slide, all the things that I talked about in stage one, phase one, you can already do that, right? You have things like promises for asynchronous communication. We have async await that makes it really easy to use. We have workers, which allows you to have actors and different threads. And we have shared array buffer for shared memory, and atomics for synchronization. What else do we have? So moving on to phase two, for web-like, we need to have ergonomic and performant data transfer. So you have all these tasks that are executing, and you have different threads that are doing stuff. You need them to have a way to transfer data more ergonomically. And ergonomic and performant code transfer. So code transfer is not something you can do right now in JavaScript, but there needs to be a way to do that. For thread-like, we would require high-level objects that allow concurrent access. So right now we have objects, right? And you can make any change you want to an object, but that can have all sorts of side effects. So you can change fields on an object, but you can have no guarantees what would happen by the end of it. So we need a different kind of object, one that can facilitate concurrently accessing. And also we need higher level synchronization mechanisms. Just by a show of hands, how many of you have ever used atomics in JavaScript? Nobody. How many of you know that atomics exist in JavaScript? There's a thing called atomics in JavaScript. Nobody. Okay, this demonstrates exactly what I mean. There's ways to do synchronization in JavaScript today, but nobody uses it because it's so hard to use. People who designed atomics don't know how to use them. So I cannot expect anybody else to do that. So what's up for phase two then? We are trying to address, if you noticed from the last slide, the biggest pain points that you have with parallel programming right now. Transferring data is expensive. Have you tried transferring data between different threads of execution? Have you tried transferring data between different processes or between different threads? The amount of transferables in the language are quite limited. You can transfer strings. You can transfer other primitives like numbers, but it's not so useful, right? You'd like to transfer objects. But what happens if you try to transfer objects within JavaScript code? If you try to transfer objects across different threads or across different workers, you get weird reparenting of prototypes. So each object has a big prototype chain, and when it goes to the other realm, well, you don't have prototype anymore. So weird. Often this makes people copy objects, deep copying mostly, and this is very slow. So we don't want to copy everything. Also, it's not just expensive, but it's completely I can't speak. Unergonomic to transfer data. If you try transferring data, it's gonna often require serialization. So you're probably trying to turn your objects into a string and then back, which is very expensive, right? You have big objects and you're constantly serializing and deserializing them. And there is identity discontinuity. What does this mean? So how many of you know that in JavaScript, objects are actually referred by reference and not by value? So if you, So if you assign an object to another variable, it's not copied over. You just copy the reference, which means that if you throw a object across the other realm and get it back, you don't have that identity anymore. You don't refer to the same object. It's different. And transferring code, as I said, is basically impossible. We transfer strings. We transfer literal code inside of a string and try to exec it, which is not a great idea, is it? So how are we going to fix that? Module blocks. OK. So do you use ES modules? No. Yes. OK. Some people use ES modules. It aims to solve the problem of sharing code. And it is spearheaded by a really nice person called Sharma. But to get into the details, JavaScript is now, well, trying to allow you to do inline modules. So you can have a module block in your code. You can say module and have code inside of that. And then you can throw this module, which is essentially in a variable, around. You can import it, which is interesting because you're not importing a file anymore. You're importing this block of code. And you can transfer this around. You can export it and import it from another module. And, well, yeah, you can do fun stuff with it. Another proposal, which is more complicated, I would say, is shared disjoint heaps. So if you know about the JavaScript heap, every object that you create in JavaScript exists on the heap, which means that, well, if you have different threads running, they have different heaps at times, which means that you cannot share objects between them. This would essentially solve the problem of both sharing data and code. And it allows developers to spin up heaps on demand. So you can spin up a new disjoint heap, right, which is completely separate from the environment you're working in, and you can pass it around. So don't want to go into too much detail, but your agent that's running the code, that's just sort of the base JavaScript system, can point into these shareable heaps. You can create a new one, you can point into them, and then you can pass them around, and then the others can do that as well. Of course, the shareable heaps cannot point back because they don't have reference to it. Yeah, so that's shared disjoint heaps. It's an upcoming proposal, so it's not out yet, but it's in the works. But let's recap phase 2 for threads. It is also, surprise, surprise, designed to address the biggest pain points. As we talked about, I asked about atomics. Do any of you use shared array buffers? Quick show of hands. No. Nobody uses shared array buffers. So we have, essentially, you realize, these different primitives for doing threading, essentially, in JavaScript. Nobody's using that. Why is that? Well, because the impedance mismatch is too high. You cannot, these primitives exist in the language, but they're not easy to use at all, which means that nobody's using them. It's a feature that exists for nobody. To solve these problems, we have a proposal called structs. So I don't know if you're hearing about this for the first time, but we're thinking of adding structures to JavaScript. What problem does a structure solve? I talked about how objects are kind of wonky when you change them from different threads, right? So you have a single object, and you're referencing it from thread. But then another thread changes the object, and you're like, OK, well, so everything changed, and now you have a race condition. But structures will not have that problem. It's spearheaded by Ujjwal, who is a great member of the V8 team. But this is what they're going to look like. So right now, you can have a class, but structures would allow you to do a struct class. And what's the difference is that you cannot change the prototype of a struct. You cannot change values. You cannot add values to the struct. And this allows you to have some level of guarantee that the object, well, in this case, it won't be an object, it would be a structure, that you're passing and sort of sharing between different threads is not going to completely change. That's it for phase 2. That's what we're doing right now. But what do we hold in the future? What's the future phase like? So for web-like, we could have lighter weight actors, right? So, okay, there's been quite a few things, but workers, how many of you use workers? At least workers, yes. Yeah, thankfully, people have used workers. But one thing that you might notice when thinking about workers is that they're very heavy, right? So it takes a certain amount of time, non-trivial amount of time, to spin up a new worker. And if you want to work in a way that quickly spins up new workers and does a tiny thing and then closes them, that's really not possible because it takes so long to spin up a worker, it's just not worth it in most cases. But if we had lighter weight actors, if we had, okay, what does an actor mean? Actor, just like a worker. But if we had a stripped down version of workers that would be fast to create, that would be fast to destroy, maybe the game would be completely changed. Maybe people would be doing things better. Maybe, don't hate me when I say this, but maybe you could have better integration with scheduling APIs. Maybe you could have a API that allows you to control the event loop. The problem is that all of this scheduling is not guaranteed to behave in a certain way in JavaScript. Each browser, each runtime does its own thing. But maybe we could find an abstraction. Maybe we could allow people to tell the event loop to do a certain thing, control it in some way. Maybe we could have a concurrence standard library. So you have the standard library in JavaScript, right? You have internationalization, and you have like a bunch of, you have temporal now. There is a standard library, but it's not concurrent. The standard library returns values. It's completely synchronous. And it doesn't allow you to get promises, for example. What if we did that? It would be great, I hope. For thread-like, well, a lot needs to be done. First of all, as is quite easily demonstrated, I guess just did that, people don't like to use it because it's so hard to do. So maybe we could have better tooling that would help people write thread-like code. Not write it better, but just write it because nobody's doing that. We could have better integration with WASM-GC. So this talk is too small to talk deeply about WASM-GC, but there's an ongoing proposal in WebAssembly to have a great control over the garbage controller. Maybe you could have integration with that, and this would allow threads to be more native. Maybe we could have a concurrent standard library with threads. So there's a lot of possibilities. There's a lot to do on this, but we need your feedback. But this is the general vision, is that we want JavaScript to be better at Multicore. We want JavaScript to scale into the future and not be stuck into the past. Before I finish, I'd like to quickly thank a few people who helped me out a lot with this work and also in the course of this presentation. And also want to thank the CDGS organizers. But mostly, I'd like to thank you. Thanks for being such a patient audience.